Okay, so today we're doing solving 1 and 2 step inequalities. Remember, inequalities are your greater thans, your less than or equal to, greater than or equal to. And in the first two problems, we're not really solving. In the first two problems, they just want us to tell whether the value is or is not a solution to the inequality. So if -4, when I plug it in for n, makes the sentence true, then we would say it's a solution. If it doesn't make it true, it is not a solution. So for problems number 1 and 2, we are not solving. We are verifying if it is or is not a solution. So we have to plug it in to do that. Okay, so let's plug in -4 for n. So we've got -3. Remember, that means multiply. So -3 times -4 plus 8. And we want to know, is that a true statement? And then 2 minus -4. So wherever I saw an n, I'm putting in -4. And then again, I'm not solving, I'm evaluating each side of the inequality symbol and using PEMDAS, and then we're going to see if it comes out to be a true or false sentence. So -3 times -4 is 12, and 12 plus 8 is 20. So we have 20 less than, and then remember we can change subtraction to add its opposite. So we have a 6 on the other side. So is 20 less than or equal to 6? No, that is false. That is not true. So that means n equals -4 is not a solution. And this is your final answer. This is your supporting evidence or work that supports how you got your answer. So this is what we're looking for as your final answer, and then we're looking for the work that supports that answer. So let's look at problem number 2. For problem number 2, we now want to plug in -3 for k. So remember, when you're substituting into an exponent, you must use a parentheses, right? So I'm going to put a -3 wherever I saw a k. So I'm going to put a -3 into each of where the k's used to be. And what we're trying to figure out is this comes out to be true or false. So remember, we're not solving, we're evaluating, and we're working out each side of the inequality using PEMDAS. So order of operations says you must do exponents first. So -3 times -3 is +9, and then 9 minus 1 is 8. And then -3 plus 3 is 0. So we have 8 is greater than 0. Is that true or false? Is 8 greater than 0? Yes, that is true. So because when I plugged in -3, I got a true sentence, that means that k equals -3 is a solution. So remember, this is your actual answer. So this is what we're looking at as your final answer. This is your work or your evidence that supports your final answer. So make sure we're looking for just your toast. So we're not looking just for your answer of yes, it's a solution, or no, it's not. We're looking for your work and your supporting evidence as to how you arrived at that. And we're looking for your correct notation. So make sure that you're using those parentheses anytime you put something in as a base. Okay, so now let's look at solving some 1 and 2 step equations. You really should already know this. Like, we've been solving 1 and 2 step equations for 4 or 5 weeks now. So it really should be an easy assignment. You just have to remember the reverse rule. So remember, this means a -1k, and we have to undo multiplying by a -1k by dividing by a -1. And did you notice I just divided by a negative number? So doesn't the reverse rule apply? So maybe on your homework you make a little documentation. So that means that -4 divided by -1 is 4, but I have to change the less than or equal to a greater than equal to. Because it said that if you multiply or divide by a -1, you're undoing your undo steps, you must reverse. Now remember, we read this going this direction because the variable's on the right hand side. So you'd read this, all numbers are less than or equal to 4. Can also read it going this direction, 4 is greater than or equal to k. So we probably want to rewrite it so that it's written with the variable first. So if we rewrite this, you don't technically have to rewrite it. That would be k is less than or equal to 4. Just make sure that you rewrite it correctly, right? So this is your algebraic answer. So all the numbers that are less than or equal to 4 all are the solutions. So for our graphing, we want to draw the 4. And remember, because there is an equal to symbol, this should be shaded, a solid dot. And we want all the numbers that are less than 4. So all the numbers less than 4 are to the left. Remember what the shading represents. The shading represents solutions. They are all the numbers that would make the original sentence, this original sentence, true. Right? So this is the graphical answer. And this is the algebraic answer. So we need to know how to graph the solutions as well as write the solutions out. So let's look at problem number 4. So remember, these are your one-step equations, so you're just undoing. So don't we have to undo subtracting 6 by adding 6? And remember, when you undo, you never reverse. The reverse rule only works if you're multiplying or dividing by a negative. And so this is our algebraic answer. So all the numbers that are less than 1 are solutions. So all the numbers less than 1 would be an open circle, and everything to the left is less than. Make sure that you're graphing in the correct direction. So make sure that your solutions are shaded, right? So the things that you shade are the solutions to the original problem. So if we had plugged in any number to the left of 1 into the original equation, it would make the sentence true. Number 5, don't we have to undo multiplication, right? And we undo multiplication by dividing. And I divided by a positive, so I do not reverse. It has nothing to do with this negative. I divided by a positive, so I do not reverse. So all the numbers less than or equal to negative 4 is my algebraic answer. Right? So any number less than or equal to negative 4 is the solution, would make that original sentence true. So open circle or shaded circle? Right, because of the equal to symbol, shouldn't that be a closed circle, or what we call a shaded circle? Make sure it's obvious, and then everything less than negative 4 would be to the left. And make sure we can tell which side is shaded. It needs to be obviously shown to us which side is shaded. So those were your one steps, right? You only had one step to solve those, right? There was only one step to solve them. Now let's look at some of our 2 steps. Okay, so shouldn't we always undo adding and subtracting first? So don't we undo addition by subtracting 2 to both sides? And remember, when you're adding or subtracting, you never have to worry. Always keep it the same direction. And then we could divide both sides now. Since we're multiplying by negative 1/4, we could divide by negative 1/4. But isn't it smarter just to multiply by the reciprocal? And isn't negative 1/4 and negative 4 reciprocal? So we're going to multiply both sides by negative 4. And did you notice, didn't we just multiply both sides by a negative? So don't we have to apply the reverse rule? So we have to change the less than symbol to a greater than symbol. So all the numbers greater than 12 are the solutions to this original equation. So this original equation, if we took any number that was bigger than 12, it would make this sentence a true sentence, right? That's what it means to be a solution. So all the numbers bigger than 12 are solutions. So it's going to be an open circle or shaded, right? It's going to be open, and anything greater than is to the right. Okay, solve the 2-step inequality. Remember, we undo adding and subtracting first. So we're going to undo subtracting by adding. And that's going to give us all numbers divided by negative 3 is less than or equal to 5. And then we have to undo dividing by negative 3 by multiplying by -3. Notice how I'm writing that. I'm not writing it down here. I'm not writing it times down here. That's not how you write it. You don't write your multiplication down there. You write it right next to the division. And did you notice didn't we just multiply by a negative? So don't we have to apply the reverse rule? A lot of you were leaving out the reverse rule on your homework. Like you forgot to apply that rule when it was applicable. So the less than equal to has to become greater than. So our answers are all numbers greater than or equal to -15 would make this sentence true. So all the numbers that are greater than or equal to -15, and because there's an equal to, that has to be solid, and greater than would be to the right. So make sure it's obvious which side you're shading. Okay, notice this time the variable's on the right-hand side. Remember, we want to undo the constant term first, so we want to subtract 10 from both sides. And that leaves us -2 is greater than or equal to, because that's 0, -2n. Did you remember to recopy the -2? And then we can undo multiplying by -2 by dividing by -2. And did you catch it? We just divided by a negative, so don't we have to apply the reverse rule? Remember, if you ever multiply or divide by a negative, so that gives me 1 is less than or equal to n, because I had to reverse my inequality. And because the variable is written to the right, we want to rewrite it and say all numbers greater than or equal to 1. So we're taking this and we're rewriting it. So this is our algebraic answer. So all the numbers greater than 1, because of the equal to symbol, would be solid, and greater than is to the right. So make sure you have your final algebraic answer, and make sure your graphical answer is shaded in the right direction. And does it have that open circle or shaded circle, and is it obvious? So it has to be very obvious. So again, your homework should be really easy to do tonight, because you guys should know how to solve 1 steps and 2 steps and even multi-steps. The only difference is knowing when to reverse or not. So shouldn't we undo the 2 by subtracting 2 first? And that gives us n divided by -3. No reversing, only if you multiply or divide by a negative. And notice we need to undo dividing by a -3, so we have to multiply by a -3. Did you catch it? Didn't we just apply the reverse rule? Didn't we multiply or divide by a negative? And we multiplied by a negative. So we have to reverse the less than or equal to a greater than or equal to, and then -10 times -3 is 30. So our algebraic answers is all the numbers that are greater than or equal to 30. So it should be a solid circle, and it should be all the numbers greater than. Okay, one more to go. We have to undo adding 5 by subtracting 5. Remember, you could have paused this tape and you could have tried to practice a couple problems before I did it, and then that way you could test to see if you were doing your work right. So isn't this coefficient like a -1? So don't we undo multiplying a -1 by dividing by -1? And did you just catch that we divided by a negative, so we have to use the reverse rule? Are we always going to use the reverse rule? No, just in these examples there happened to be a lot of them where we had to reverse. Right? And then we got this backwards, so we probably should be a good idea to rewrite it. So n is greater than 7, n is greater than 7, because we read from left to right, so it makes more sense to have the variable on the left. So all the numbers that are greater than 7, that means open circle, would have to be to the right of 7. So let's see what we got. Oh, it looks like we left one out. We left number 8 out. So let's do number 8. So shouldn't we add 4 to both sides? And that would give us 10 is less than 1/2 k. And we could divide by 1/2, but isn't it smarter just to multiply by the reciprocal? And notice I'm not going to reverse, right? I'm not going to reverse because I multiplied by a positive. So we want all the numbers that are bigger than 20. So all the numbers bigger than 20 are going to be to the right, because we probably should rewrite that as k is greater than 20, right? So look at all the work, nice and neat and organized, and the graphical answer. Okay, solving 1 and 2 steps. If you multiply or divide by a negative, you must remember the reverse. So that's the reverse rule.